Hello everyone and welcome to my talk at Qubes OS minisummit 2021. It would be about history of USB camera support in Qubes OS. So my name is Piotr Król. I'm founder of 3MDEP Embedded System Consulting. I'm a core contributor and maintainer, conference speaker, organizer, co-organizer, trainer of various organizations. Recently involved in open security training too. I'm also a former Intel BIOS software engineer. I'm 12 years in business and probably for more than 5 years working with Qubes OS as user, and maybe a little bit as bug reporter and starting to do some small development, small scripting around it. I have C-level position in various organizations, which logo you can see on this slide. And maybe a little bit about 3MDEP, who we are. We are a core boot licensed service provider since 2016. So we develop core boot, port this to various platforms. We are participant in core boot leadership call. We are UEFI adopters since 2018. We are Yocto participant and embedded Linux expert since 2019. We are also official consultants for Linux Foundation FWPD-LVFS project, which is responsible for firmware updates of Linux devices. We are also IBM Power member, IBM Open Power Foundation member since last year. What we will talk about today, I will explain the goal of the presentation, why USB is hard, like a little bit about USB endpoints, but we don't want to go into USB technical details here. More show solution that applies for Qubes OS, USB device security and how Qubes OS deal with it. Little bit about camera issues in Qubes OS, and then Qubes Video Companion introduction to the project as a solution to various issues that happened over last years. Then I will show you the demo that I recorded with Qubes Video Companion and tell you how you can help the project to improve it. Yeah, so the goal of the presentation is to discuss history of USB camera support. There will be not much about the history because I have just one slide. There's not much that happened around that in terms of number of features or number of issues, but it's kind of a lot in terms of code and how complex is the problem. Yeah, and then I will show the demo of Qubes Video Companion, which approach the solution in a little bit different way than it was before. Just for your information, you may see some glitches here or some delays in this video, and this is maybe because or thanks to Qubes Video Companion and my kind of not so performing setup. But I'm very happy to record that on Qubes OS. I always had to set up another laptop without Qubes to record everything because I had problems with my Logitech camera, and right now I can use my camera, and that's what's very important for me. Why USB is hard? So first of all, USB is a relatively complex protocol. It has thousands of pages of specifications. There are multiple host controller implementations. So host controller is the piece on your laptop, on your workstation, which is piece of hardware that will talk with USB devices to establish communication and provide support in your system. There's also a massive market for USB devices. There's lots of them. Some of them weakly comply to the specification, and this is part of the problem. So first of all is complex protocols. Second of all, there are multiple host controller implementations with various quality of the drivers. And then finally, there are also multiple devices that are not exactly made the same. From open source firmware vendor perspective, USB is the area causing the most problems in stable projects. So let's say we have PC Engines, our firewall that we're maintaining for more than 5 years, and there is a lot of USB problems there with compatibility with timings, with enumeration for booting. Most of the times it works, but there are some corner cases that every time users find some corner case, some device which has glitches. There are multiple endpoints with various requirements. I will talk about endpoints on the next slide. But those endpoints which are in USB devices have different transferred data types, and different requirements for those data, and because of that, this also even more complicates the situation. Okay, so how typical setup look like? So we have our host controller, which is in our laptop. Then we have some connection which going to the device. Over this connection, there are endpoints exposed from the device. There is one control endpoint and one or more data endpoints. And between those endpoints, there are logical pipes which are used to transfer data and exchange information. What's going on in the device, to establish use of that device, to understand what device we're dealing with and what kind of drivers we should use, and so on and so on. And this is roughly how it looks like. USB device can have even 32 endpoints, so this can be quite complex device. What is important to know is that we have three types of transfers used in USB devices. There is bulk transfer, which are large but sporadic data transfer, typical for storage devices, USB sticks, and this kind of devices. There are interrupt data transfers. Those are in devices requiring quick response, like mouse, keyboard. So we need immediate. There is need for minimal latency, and immediate response is required for those devices to make them work. And finally, there are isochronous data transfers, which are typical for video and audio. So that means there is some guaranteed data rate at which the data coming to the system. There may be some delay here, and that's acceptable, but still this data rate cannot vary because quality can jump, and that could be problem in the user experience. Some of the devices can combine multiple endpoints. That's also kind of part of the problem if one driver wants to handle that. So typically, recently we have cameras with microphones built in. How the USB device security look like? So there was a good paper from Nassim, Yahalom, and Elovici in 2017, categorizing and listing how many USB attacks we had. So we can divide USB attacks in 4 groups, or 3 groups and two subgroup in one of the groups. So one of the attacks are programmable microcontrollers. Those attacks are like rubbery duck and various other attacks that rely on the microcontroller inside USB device to be dedicated, programmed to be malicious device. Yeah. So there are a bunch of attacks that use that. And so what happened in that situation? We connect USB device, and either it can take over our system or damage that in irreversible way. The USB peripherals also can be compromised. So there are 2 other types of attacks. One of the attack is that someone, when we have our USB device connected, can reprogram that device because of the firmware upgrade mechanism built in the USB device, and that can cause various problems. And we see here some smartphone-based human interface device attacks. We see DNS override attacks. We see keyboard emulation by modified USB firmware. So so assuming that someone connected our USB device to the compromised system, this compromised system may update the firmware in the USB device, and that USB device starting to be malicious. So this is different from the class A. because in class A it is like designed to be malicious and to be dangerous for our systems. In class B1 we have modification of the firmware. In class B2 there is no reprogramming, but the content of the USB device is already created or exists there in a way that system that it will cause damage to the system. And one of the great example of that was Stuxnet, which used LNK capabilities and kind of auto opening of LNK, and this caused infection of the system. There were various auto-run exploits used that technique, so that means it leveraged the content of and the problems in the system. It may leverage also the problems in the driver stack. There are various ways of leveraging this problem. And finally, electrically, the USB stick or USB device can be designed in a way to just smash our USB port or our whole computer, and there may be other electrical designs that causing problem to USB. So we see that there is a lot of attacks that we want to prevent. Of course, the electrical one are very hard to prevent because we would need some hubs or something that divide the device and our system, and of course hubs can be another point of failure, point of problem. But other classes can be prevented to some extent, and let's see how Qubes OS dealt with that during the evolution of the system. So in Qubes 2.0 there was added experimental support for PV USB. So it started with some isolation of the devices and how those devices are used in the system. It leveraged some basic features of the hypervisor, but from the beginning this was unstable and unmaintained code, and that's why this didn't go well and caused some problem. In 3.1 there were Qubes OS added out-of-the-box support for USB VM with support for the mouse. So the mouse already is isolated from the system using it. Then in Qubes 3.2 there was support for QVM USB. So that means we already have USB pass-through capability, and we can decide what device connected to our laptop or our workstation goes to what VM, and we can disconnect and connect on demand our USB devices. This built way better isolation, and then of course thanks to the existence of sysUSB, every USB device is connected to dedicated VM, and this is kind of where the problems may happen, and this problem have to break to the virtualization boundaries to access anything else, which is very good because it limits the attack surface of potentially malicious USB devices. In 4.0 there was system try widget added to easily, from the user perspective, handling connecting and disconnecting USB devices. So how this worked? So let's say on the right we have some USB device. Let's say this is camera. We connect that camera like typically we did the PCI pass-through of the USB controller to sysUSB. sysUSB handling all the USB connectivity, driver applying, and so on. But first of all, it has to support our host controller. So on the bottom we got USB host controller driver. Then we have some USB core driver which handle all the like main stuff related to USB, and then we have stub driver which gives ability of transferring the USB packets over the QR exec, and in that way we can limit any action triggered on the host controller or USB core functionality, because if anything will be wrong, this will happen in sysUSB and will not be exposed to our app VM. But the app VM thanks to the virtual host controller interface, which is on the bottom of the stack, can connect and take packets from the USB device, and then through USB core and through USB physical device driver can expose real functionality to the system. And that is great, and it works very well for bulk devices. But and so this architecture leverage USB IP project, which is very interesting project, already merged into the Linux kernel. So which kind of gives also ability to expose everything over IP network, but in case of Qubes, it is used over QRexec. And what's the limitation of this configuration? The stack here, so our ability to transfer the packets from the sysUSB to AppVM is kind of limited and primitive, because anything which is time sensitive will have some problems. First of all, so that's why like bulk endpoints, so bulk transfers are not very time sensitive, and those work perfectly. But isochronous endpoints may cause problems in that situation, and people already said that there are some performance issues. They see like things that sometimes work, sometimes doesn't work. So it really depends on the device and what kind of complex USB features it uses. And the problem with the USB IP stack is that it's not very well maintained. It has some unimplemented methods. For example, VHCI get frame number is the one which happen very often in the logs. If we have device which got multiple endpoints and those endpoints have to be redirected to AppVM, this also might rise complexity and cause problems. And finally, there is still security risk because in this configuration we still expose the device, despite it is to some layers of the USB stack processing are limited and isolated in sysUSB. But we still expose key features of the device into AppVM. So this may cause that firmware of the device cause some problems, or some may perform attack on AppVM USB stack. Because of rising need for remote work, the priority of support for cameras and especially like why we're saying about cameras are the complex USB devices, typically got multiple endpoints. They're using isochronous transfers, and because of that, those transfers are time sensitive, and USB IP had some problems handling that correctly. So even there are some, this problem is very important to support USB cameras in Qubes OS, because we even saw some people commenting that they resigning from using Qubes OS because of lack of support for USB camera. But this changing definitely, like there are developers who listening community and want to change that. And despite all the issues reported, like cannot use a USB camera, which was created in 2018, like kind of a couple of participants, there are like quite a lot of comments, and this was initially created for Logitech C217. And there were even some suggestion about a trusted stream. So the concept of isolating video stream and just providing video stream to the AppVM and getting rid of exposing whole USB stack is quite long here since 2016. There are also forum threads about Logitech 922, the camera that I'm using right now during this recording, and you can see it has quite a lot of view. There are some security papers which also raise the concern of the web camera security. For example, the paper about disabling the MacBook web camera LED indicator, which of course, like when we disable that, we think camera is not active, but it still may be active and working, and we don't know about that. Yeah, and there is also a paper about preventing covert webcam hacking in the civilian and government sector. It classifies and shows various potential attacks using web cameras. What about Qubes Video Companion? So Qubes Video Companion is the new answer to all these issues. project was created by Elliot Killick in September 2020 with the goals of securely streaming web cameras and sharing screen across VMs. It is MIT licensed source code available on GitHub under the address that you see on my screen. It was initially written in Bash, so it's like Qubes RPC service, initially written in Bash and then rewritten with the support of Demi to Python. And yeah, so right now it is in version 2.0, which I will use for this presentation. And we think this is a very good candidate for being part of the core Qubes OS, and I believe Marek also agreed to that based on the email discussion. And this is the plan for the project. What kind of features this project has? First of all, it has system try icon and notification while streaming or sharing. So user is notified whenever a camera is enabled, disabled, and whenever something happens with streaming or with screen sharing. This is very good because this prompts user, and it's very hard to do that being unnoticed by the users. Then there is guarantee one-way communication from video sending domain to video receiving domain. So the domain that owns the camera, in our case typically sysUSB, just sends the video stream. There is no additional control endpoints exposed or some additional camera features exposed. So there is just pure video sent. And that's very good because this is what we need from user perspective. And we want isolate, thanks to that we can isolate the place where hardware is handled, the place where potentially malicious camera can exist from the place where we're using. Then there is minimized attack surface of video receiving domain because there is GStreamer used. It uses video capabilities that's strictly saying what I want to receive with what parameters. I don't want anything else, and these capabilities are verified on both sides of the. First, there are filtered on the receiving domain, and first they are filtered on sending domain, and then verified on the receiving domain. The kernel modules related to exposing the device are also reloaded between the sessions, which adds additional security, so there is nothing left in the memory. So this is kind of additional support. There is no direct to access by video receiving domain, and that's obvious because we're using GStreamer for passing the video. And there are many others, many other features explained and listed on the GitHub repository. How this look like from the software stack perspective? So on the right we have our camera, which typically expose some video 0, video 1 device. This device is consumed by GStreamer v4L2 SRC component. Then through QE goes to capabilities filter, which first sets some parameters for the and some expectations for the incoming video stream. Then the project use JPEG decoder, also checking and setting capabilities for the exposed file descriptor sync, and this file descriptor sync is exposed over QRexec to our app VM, or in this case I call it video receiving VM. Then one more time we're using GStreamer. GStreamer consume the file descriptor exposed by sysUSB, and then through QA also checks capabilities of the stream. There is also GStreamer raw video parser, and the GStreamer pipeline ends with GStreamer v4L2 sync, which creates local dev video 0 device that can be consumed by potential video applications like OBS Studio or Jitsi or whatever even Zoom is supported, so whatever we're using. Then what I didn't say, I believe I said most of what I wanted for this slide. How you can install that, assuming that you're using version 2 tag, you're just cloning the repository. The version 2 tag should be already checked out. you just for Debian you can use build create deb script. This script verifies the tag. Check out the most recent tag. Verifies this tag and install all the required components, and finally compiles the deb package, which is then available on the directory above Qubes Video Companion directory. There is also other script for RPM based distributions, but I'm using Debian, so I did that for Debian. I checked it for Debian. Then you can install that file in your Debian template. Thanks to that, it would be available to all the VMs based on that template, and there is need also to compile the v4l2 loopback kernel module, and there is script for that. Works without any problems. Then you just disabling your template VM and can restart VMs which are based on Debian 10 template, like sysusb or whatever video receiving VM you're using. Of course, you need to connect your camera to sysusb, and then you can run with your video receiving VM Qubes Video Companion. Okay, there should be not / because you have that already installed. Depends how you will do that, but if it's installed, it should be available in your path. But yeah, you're calling Qubes Video Companion webcam, and then you're getting pop-up about where's the video sender. So video sender is connected to sysusb, and in that way you see the icon in the try that the video and notification that the video is shared between VMs, and then you have the video 0 exposed in your VM and can use that with your application. So I checked some performance. Right now I'm recording this with the VM that got 4 vCPUs and 12 gigs of RAM. According to my discussion with Elliot and Marek, the CPUs are the most important thing. So better CPU, better performance of this solution. I used Jitsi with Chrome 91 and works seamlessly. For this recording, I'm using OBS Studio version 001, which is like very old version, and probably we could get something way better right now. But I use something which is like directly from the apt repository on my Debian. In case of performance issue, you can always minimize the preview window. You can even disable the preview window in OBS. There is in context menu there is enable preview position. If you uncheck the mark for it, it will be disabled, but still will record. You may like to avoid playing any videos in the same time, so disable any YouTube session or whatever you have in your browser, because it's eating processor power, and you can assign more vCPUs to the VM to make it perform better, and that's completely fine, because this is typically when you're recording something or you have a call, you would like to focus on that call and not watch 5 other videos in the background. Okay, so let's try to play the demo. First of all, I will start Qubes Video Companion, and you can see that with the webcam, you can see that I have notification on the right top side. Now I have to install OBS Studio because it's not there. And you can see that the notification showing webcam sysusb to work. So yeah, this is the direction of exposing video stream by GStreamer. Yeah, and I started OBS, and yeah, this is how it looked like a little bit old look, but it works fine without any issues. Microphone also works fine. Yeah. There may be slight delay if you have if your processor is loaded. Now I'm using Chrome to show you Jitsi. Yeah, and you can see that Jitsi also works fine. Yeah, enabling, disabling camera works well. And probably the most popular application for testing, Cheesy. Yeah, so I have to install it. Yeah, and you can see it also works fine. Yeah, so that's it with the I'm just playing a little bit with it, but that's mostly it for the demo. Okay. No, this is not what I wanted to do. Okay, so yeah, so how you can help with improving that project? First of all, test. We need more testing. We need more reports about working hardware, with what hardware it works well, with what hardware it has problems. Maybe there is something there should not be, but it should work with most of the setups, but who knows? We need more information about user configurations. Like we don't want you expose your privacy like sensitive stuff, but it would be great to know what kind of CPU was used and how the performance was and how many vCPUs you connected to your VMs. And thanks to that, this project could be improved and we could give better guidance for the users how to use it and what it requires to perform well. Potential issues that I see is that any kernel update of the Debian 10 template or whatever template you will rely on will require compilation, recompilation of the v4L2 loopback driver. Yeah, so this could be solved by packages, but yeah, I believe if this would be added to core Qubes OS, this would be solved. And one of the future ideas is integration with sysusb try icon. I know that the icon right now is completely separated, and that's the kind of the purpose of the project also. But on the other side, that means that trying to redirect cameras using sysusb try icon either should be disabled or something because people may still use sysusb instead of Qubes OS Video Companion. And yeah, Qubes Video Companion works fine for like complex cases, and yeah, just to avoid to providing this feature in kind of two ways which can be incompatible or can have some problems. Maybe this should be solved or is kind of integrated in consistent user experience. And that's it. If you have any questions, let me know. I hope that you enjoyed this presentation and you will use and help improve this project.